Hello, everyone, and welcome back to my online teaching platform. Still on find the derivative of a function from the first principles. We have a function here, and we have to find its derivative using the first principles. All right, so let us get the function that we are to find the derivative for. So I have the function here to be y is equal to the square root of x minus x squared. Now you could see that the function has a radical part and a quadratic part. So we can split this function into two. So that you take the first part, we find the derivative, you take the second one, find the derivative, then you bring the two derivatives together to get the derivative of the given function. So that's what we'll be doing now. So our first one, we can name it as our y1. So we take our first one, we can take this part to be, so we take this one to be the first part, and we take the remaining one to be the second part. All right. So I can take the first one, which is the square root of x, to be my y1, which implies that my f of x 1. So I'll put f1 of x is equal to square root of x. Then I'll also name the second part as x squared, which implies that my f2 of x is equal to x squared. All right, it should be minus, so I'll bring the minus here. It should be negative x squared. All right, so we differentiate each of them. So we are going to start with the first one, which is our f1, our f1 of x being equal to the square root of x. All right, so we need to find our f1 of x plus h, which will be equal to square root of x plus h. So we plug in x plus h for x in the function. So let us find our dy1 dx. So we get it to be the limit as h approaches 0. Then we have our formula to be f of x plus h minus f of x all divided by h. So that's what we'll be using. We know our f of x plus h, which is f1 of x plus h. So because we are doing the first part, I'm using one to differentiate it from the second part of the function. So here will be the limit as h approaches 0. Then our f of x plus h, we had a square root of x plus h. Then our f of x, which is the original function, square root of x, all divided by h. Alright, so we'll be getting the limit as h approaches 0. Now you can see that we have a set as part of the numerator, so we need to rationalize it using the conjugate of the numerator. So we are going to get square root of x plus h minus square root of x all divided by h, then multiplying the conjugate of the numerator. So we will be getting x plus h, then here becomes now plus square root of x divided by the same thing, square root of x plus h, plus the limit as h approaches 0. Then the numerators will multiply each other, so we can apply the concept of difference of two squares over here. So we are going to get square root of x plus h squared minus square root of x also squared. And we'll get a denominator where the h will multiply the second denominator. So we are going to get square root of x plus h plus square root of x in one bracket. Alright. So the numerator we are going to get, let's bring our limit as h approaches 0. In the numerator we'll be getting x plus h, because when you consider this one, the square cancel the square root, the square here also cancel the square root. So we'll be left with x plus h minus x, all divided by h multiplying square root of x plus h plus square root of x. Alright, so when you look at the numerator, we have x minus x, so that will give us 0. So we will be left with h being the numerator of the fraction. So we'll be getting h divided by the product of h and square root of x plus h plus square root of x. Alright, so we have to simplify. You could see that the h here cancels this h, since the h is common to all the terms in the bracket, this particular bracket. So the h is common to all of them. So the h here cancels the h in the numerator, and we'll be left with the limit as h approaches 0. We have 1 divided by square root of x plus h plus square root of x. Alright, so we can now plug in the value of h, and that will give us 1 divided by square root of x plus 0 plus square root of x. And this will give us 1 divided by square root of x plus square root of x. So we can now add the square root of x to the second square root of x, since they are like set. So we are going to get 1 divided by 2 square root of x. Alright, so this becomes our dy1 dx. So we need to now work on our dy2 dx. So let us bring back our y2. Our y2 is equal to negative x squared, and our f of x in terms of the second function will be equal to negative x squared. So we need to find our f2 of x plus h, and that will be equal to negative. Then wherever you see x, you plug in x plus h. So it's going to be x plus h squared. Alright, so we can now plug in the values. So we have our d2 dx. Oh, sorry, not d2. dy2 dx is equal to the limit as h approaches 0. Then we have our f2 of x plus h minus our f2 of x divided by h. Alright, so we just plug in the values. We are going to get the limit as h approaches 0. Our f2 of x plus h is negative bracket to be x plus h all squared minus our f2 of x, which is negative x squared. Alright, so all divided by h. So we continue to simplify. We will be getting limit as h approaches 0. So for the first one, the first bracket where we have x plus h all squared, that's a perfect square. So we maintain our negative outside, And whatever we get in the bracket, we use the negative one to expand it. So we have x squared plus 2xh plus h squared minus negative x squared in bracket nicely. Let me close this bracket, all divided by h. So we continue to evaluate, we have the limit as h approaches 0. So in the first bracket, when you expand through, you are going to get negative x squared minus 2xh minus h squared. Then here we have negatives. So negative times negative x squared will give us positive x squared, all divided by 8. So we have negative x squared here plus x squared. We are going to get 0. So we continue to get the limit as h approaches 0 to be negative 2xh minus h squared, all divided by 8. So we can now simplify where h will divide each of the terms in the numerator, and that will give us limit as h approaches 0 to be negative 2x minus h. So this h, the h will divide each of the, or you can rewrite it as, we factorize h out, that is h, then bracket to be negative 2x, then we have minus h, all divided by h. So without this, we cancel this. Right. So we can now plug in the value of h. So we will now take the limit. We have negative 2x minus 0. So the dy to the x is equal to negative 2x. So we can now bring the two results together to get our dy dx. So we have dy1 dx plus dy2 dx. So the first one is, we had it to be 1 divided by 2 root x. Then the second one, we have it to be negative 2x. Right. So at the end, our derivative or our dy dx will be equal to 1 divided by 2 root x minus 2x. Thank you for watching, and do not forget to subscribe to my YouTube channel, Math with Ebefa. Bye.